Today's lesson is on equations involving and the denominator. The opening exercise says, Nolan says that he checks the division problem by performing multiplication opposites, so he's using the opposite operation. For example, he says that 20 divided by 4 is equal to 5 is correct because 5 times 4 is 20. Or just working backwards, 5 times 4 is 20. The same thing with 3 divided by 1/2 is equal to 6. That's correct because if we take 6, multiply it by 1/2, we should get 3, and we do. So now let's use Nolan's reasoning to explain why there is no real number that is the answer to the division problem 5 divided by 0. So, if we look at this, we have 5 divided by 0, we're just going to say that's equal to some number n. I'm just calling it n. Just any number. So looking at this, with Nolan's explanation, we're going to have that n times 0 should equal 5. And if we look at that, can we think of any number as n that if we multiply by 0, we get 5? Well, if we really think about it, any number times 0 is 0. So any number times, there is no such number, n, that if you multiply by 0, you should get 5. So, that's what we can say, that there is no such number that n times 0 would equal 5. Okay? So now looking at this, Quentin says that 0 divided by 0 is equal to 17. What do we think? Well, if we do 0 divided by 0, so we'll have 0 divided by 0 is equal to 17. Well, with with Nolan, the way that he explains it is that you have to do 17 times 0 is equal to 0. And while that is true, okay, that 17 times 0 is 0, we can't use this because we should always know here that you can never divide by 0. So we could say, well, it's true that 0 times 17 is equal to 0. We cannot divide by 0. So we can't have 0 divided by 0. Okay? Now let's look at Mavis. Mavis says that the expression 5 divided by x plus 2 has meaningful value for whatever value we have chosen to assign for x. Do you agree? So if we look at this, so what if if we're looking at x, what if we had a value of x is equal to negative 2? Let's look and see what would happen. So what if x is equal to negative 2? Because if we look at this at negative 2, if we would substitute it in, we would have 5 divided by negative 2 plus 2. So we'd have 5 over 0. And we can't have 5 over 0. So, this expression does not have meaningful value when x is equal to negative 2. Because when x is equal to negative 2, we have 5 divided by 0, and we can't do that. Okay? So let's move on to the next one. Bernoy says that the expression 3x minus 6 divided by x minus 2 has the value 3 for whichever value one can assign to x. And do we agree? So if we look at this, if we had 3 3x minus 6 divided by x minus 2. On both sides, if we look at this, we're going to multiply, I'm going to multiply both sides, I'm going to multiply this expression by x minus 2. So what we would get was we would get 3, well, if we're looking at this, we're not going to multiply by x minus 2, I'm wrong. What we're going to do is we're going to factor the top. Well, we have 3 and we have 6. What's common between the 3x and the 6 is a 3. So I'm going to factor out a 3. 3x divided by 3 is just x. Negative 6 divided by 3 is a negative 2. Divided by x minus 2. And if we look at this, x minus 2 will cancel with x minus 2, and we will get 3. But again, looking at this, what if we assigned x to be negative 2? What happens when x is negative 2? Well, we saw in the last example, if we plug in negative 2 here, we can say that we can't have x to be equal to negative 2. But any other value except negative 2 will work. So here we have but x cannot equal negative 2. So we could say, do we agree? Yes, we do agree for all values except negative 2. Because when x is equal to negative 2, then we're going to divide by 0 here, because negative 2 minus 2, positive 2. So x could not equal positive 2. So for all values that x is equal to positive 2, it would not work. Okay? So now let's go into exercise 1. If we look at exercise 1, they want us to rewrite 10 divided by x plus 5 as a compound statement. And with this, they want us to look at the denominators, x plus 5. So we know that 10 over x plus 5 will work for any values we assign to x, except for if we have x is equal to negative 5. Because if we have x is equal to negative 5, we'd have negative 5 plus 5 and have 0 in the denominator. And we can't have 0 in the denominator. So if we're writing this as a compound statement, we can say that we can have 10 divided by x plus 5, and we can have that x cannot be equal to negative 5. And then there's our compound statement. Okay? So now let's look at our next example. Exercise 2. It says, consider x squared minus 25 divided by x squared minus 9 times x plus 4. And it says, is it permissible to let x is equal to 5 in this expression? Well, let's go through and let's try it. So we're going to let x equal 5. So wherever we see an x in this equation, we're going to substitute in 5. So here, we're going to have 5 squared minus 25 divided by 5 squared minus 9 times 5 plus 4. So we have 5 squared, which is 25, minus 25, divided by 5 squared again is 25, minus 9, times 5 plus 4. So, in this case, we could just simplify. 25 minus 25 is 0, divided by 25 minus 9 is 16. 5 plus 4 is 9. So we're going to have 0 divided by 144, because 16 times 9 is 144. And then 0 divided by 144 is just 0. So it is permissible or that we can have x is equal to 5, because if x is equal to 5, then we get an answer of 0. But let's look at the next one, b. It says, is it permissible to let x is equal to 3 in this expression? Well, let's let x equal 3. And wherever we see an x in this case, we're going to plug in a 3. So we would get 3 squared minus 25 divided by 3 squared minus 9 times 3 plus 4. So in this case, we're going to have 3 squared, which is 9, minus 25, divided by 3 squared again is 9. So we're going to have 9 minus 9, times 3 plus 4. If we look at this, 9 minus 25 is negative 16, divided by 9 minus 9 is 0. 3 plus 4 is 7. So we're going to have negative 16 divided by 0 times 7 is 0. And in this case, we have 0 in the denominator, so we know that we can't use this one. So we're going to say, no, it's not permissible to let x is equal to 3, because then you get negative 16 divided by 0. Or you just get 0 in the denominator. So looking at this, they want us to give all of the values of x that are not permissible in this expression. So basically, if they're looking at this, we're going to just look at the denominator. And if we look at the denominator in this case, we have x squared minus 9 can't be 0, and x plus 4 cannot equal 0. So let's find those values for x squared minus 9 is equal to 0. And we have x plus 4 is equal to 0. So if we were looking at this, we would have to, again, solve for x in this first case. So what I'm going to do is I'm going to add 9. Add 9. So we get that x squared is equal to 9. And then what we have to do is we have to take the square root. Because if we have x squared and we want to get x, let's take the square root of both sides. So the square root of x squared, the square root of 9. And remember, when we take the square root of a number like 9, we have to take the positive and negative case. The square root of 9 is 3. So we're going to have x is equal to positive 3 and x is equal to negative 3. And if we have x plus 4 is equal to 0 on both sides, what we're going to do is subtract 4. Subtract 4. So we get that x is equal to negative 4. So positive 3, negative 3, and negative 4 are all values of x that are not permissible for this equation. So we could say that x could not be equal to positive 3, x could not be equal to negative 3, and x cannot be equal to negative 4. So these are all the values of x that will make the equation have a denominator of 0. So then it would mean that they're not permissible in this equation. Let's look at example 1. Example 1 says, consider the equation 1 over x is equal to 3 over x minus 2. They want us to rewrite the equation into a system of equations. And what they mean by a system of equations is we're going to write the original equation and then write all the values of x that is not permissible in this case. So we have this first one, we have 1 over x is equal to 3 over x minus 2. And if we look at the first denominator, if this was 0, if x was equal to 0, then it would not be permissible. So x cannot be equal to 0. And in this case, x cannot be equal to 2. So there's our system of equations. And we can either put an and here, or we can put a list. So we know that we have this first equation, and x cannot be equal to 0, and x cannot be equal to 2, because that would make the two denominators 0. So, for part B, they want us to solve the equation for x. And they say, excluding the values of x, that the denominator would be 0. So we're going to exclude 0, and we're going to exclude 2. Okay? So let's go through and let's solve this. We have 1 over x is equal to 3 over x minus 2. And since we have an x in the denominator and x minus 2, our common denominator is going to be x times x minus 2. So on both sides of the equal sign, we're going to multiply by this common denominator of x times x minus 2. And then on this side, so we're multiplying by that, we're going to multiply by x times x minus 2. Okay? And if we're x divided by x, we'll cancel. So we're just going to get 1 times x minus 2 is equal to x minus 2 here will cancel with that x minus 2. So we're just going to get 3 times x, or 3x. So we're going to get that x minus 2 is equal to 3x. Then what we have to do is we just have to solve for x. So in this case, I'm going to subtract x. So I get that negative 2 is equal to 3x minus x is a 2x. And then I'm just going to go up over here. So that if we have negative 2 is equal to 2x, we divide by 2, and we get that x is equal to negative 1. So if we look at this, we want to write our solution. So x can equal negative 1, and x is not equal to 0, and x is not equal to 2. So this is our solution. Okay? So let's move on to the next one. Example 2. In example 2, they want us to consider the equation x plus 3 divided by x minus 2 is equal to 5 divided by x minus 2. And if we look at this, they want us to rewrite the equation into a system of equations. So in order to write it as a system of equations, we have to look at the denominator. What will make that denominator 0? Well, if we have x minus 2 and x minus 2, if we set x is equal to 2, we'll have 2 minus 2. That will give our denominator of 0. So what we have is our original equation, x plus 3 divided by x minus 2 is equal to 5 over x minus 2. And we also know that x cannot be equal to 2. There's our equation, our system of equations. So they want us to solve the equation for x, excluding the value of x that leaves the denominator of 0. So looking at this, I'm going to have x plus 3 divided by x minus 2 is equal to 5 divided by x minus 2. And in this case, we have to find the common denominator. Well, our common denominator is x minus 2, because there's an x minus 2 and an x minus 2. So what we're going to do is multiply both sides by that common denominator of x minus 2. So those will cancel, that will cancel, and we'll get that x plus 3 is equal to 5. And then in both cases, to get x, what we're going to have to do is we're going to have to subtract 3 on both sides. So subtract 3. On the left side, we'll just get x. 5 minus 3 is 2. So x is going to equal 2. And x is not going to equal 2. So in this case, if we found out that x is equal to 2, and we know that x can't be 2 from our equation above, our solution set is going to be the empty set. So we could say that the solution set is going to be the empty set or the null set, or if we were doing the set notation, we could just do our curly brackets with a blank in the middle. Okay? Because, looking at this, we just solved it and we got that x is equal to 2. And we found out up here that x is not equal to 2. That's different than the example that we had before, the last example, because here, when we solved it, we got that x is equal to negative 1, and negative 1 isn't restricted to not be a value of x. So that's why we could use this one. But in this example 2, we couldn't use our solution because we got 2, and we know that x cannot be equal to 2. So, let's move on to the next one. For exercise 3 to 11, they want us to rewrite each equation into a system of equations, excluding the value of x that leaves the denominator of 0. Then, after we do that, we want to solve for x. So looking at this, we have 5 divided by x equal to 1. So we're going to have our original equation, 5 divided by x is equal to 1. And in this case, since the denominator is just x, x cannot be equal to 0. So this is our system of equations that we have here. Okay? And now what we're going to do is we're going to solve for x. So we have our original equation, 5 over x is equal to 1. On both sides, I'm going to divide by a common denominator, which would just be x multiplied by x. So x is going to cancel with x. So we'll get 5 is equal to 1 times x is just x. So we get that x is equal to 5. So our solution set is that x is equal to 5 and x is not equal to 0. So our solution set is just going to be 5. Okay? Let's look at number 4. So if we look at this, we're going to first write it as a system of equations. So we have 1 divided by x minus 5 is equal to 3. So we'll have our original equation, 1 over x minus 5 is equal to 3. And we know if we look at our denominator, x minus 5, what will make that 0 is if we have x is equal to 5, because 5 minus 5 is 0. So we know that x cannot be equal to 5. So now what we're going to do is we're going to go through and solve our equation. So if we have 1 over x minus 5 is equal to 3, on both sides we're going to divide by a common denominator. And since this denominator is just 1, because we could say this is 3 over 1, we're going to multiply both sides by x minus 5. In this case, the x minus 5s will cancel, and we'll just have 1. And we'll have is equal to 3 times x minus 5. So, now to solve for x, we're going to have to use our distributive property and distribute the x. So we're going to have 1 is equal to 3 times x is 3x. 3 times negative 5 is negative 15. And then now we just have to go through and solve for x. So we're going to add 15. Add 15. So we get that 1 plus 5 is, or 1 plus 15 is 16 is equal to 3x. Then what we're going to have to do is divide by 3. Divide by 3. So we're going to get that x is equal to 16 over 3. So our solution set, since we didn't get x is equal to 5, not equal to 5, our solution set will be 16 over 3. Okay? Now let's move on to exercise 5. For exercise 5, we have x divided by x plus 1 is equal to 4. So if we look at this, we're going to have our first equation, x over x plus 1 is equal to 4. And on both sides, on our denominator, x plus 1, what can x be for this denominator to be 0? X cannot be equal to negative 1. Because if x is negative 1, we'd have negative 1 plus 1, which would equal 0. And that would have the denominator of 0, which we can't have. So, if we were looking at this, let's go through now and solve. So we have x divided by x plus 1 is equal to 4. So on both sides, we're going to multiply by the common denominator, x plus 1. So let's multiply the left side by x plus 1. Multiply the right side by x plus 1. X plus 1 on the left side will cancel with the other x plus 1. We'll just get x is equal to 4 times x plus 1. And if we look at this, we're going to distribute the 4 to both terms. So we get that x is equal to 4 times x is 4x. 4 times 1 is just 4. So we'll get x is equal to 4x plus 4. Now what we got to do is we have variables x on both sides. So what we have to do is we have to get x, the x is on one side, so we're going to subtract 4x, subtract 4x, 1x minus 4x is negative 3x, is equal to 4. And then if we divide, so we have negative 3x is equal to 4, so we're going to divide by negative 3, divide by negative 3, and we're going to get that x is equal to negative 4 over 3. And since negative 4 over 3 is not equal to negative 1, we know that our solution set can be negative 4 divided by 3. Okay? And then the last example for this page, number 6, we have 2 divided by x is equal to 3 divided by x minus 4. So if we're writing this, so we have 2 over x is equal to 3 over x minus 4. And in this case, if we look at the denominator, we have x, so x cannot be equal to 0. And we have x minus 4, and that can equal 0. So x cannot equal 4. So now let's go through and let's solve our equation. So we're going to have 2 divided by x is equal to 3 over x minus 4. And we look at the denominator, x and x minus 4. What is our common denominator there? We're going to have x times x minus 4. So we're multiplying both sides by this common denominator of x times x minus 4. So now what we're going to do is we can have x will cancel with x. So we're going to have 2 times x minus 4 is equal to, this x minus 4 will cancel with that. We'll have 3 times x, or 3x. Then if we look at this, we're going to have to distribute the 2. So distribute this 2 to both terms. 2 times x is going to be 2x. 2 times negative 4 is a negative 8 is equal to 3x. Then what we're going to have to do is on both sides we're going to subtract 2x. Subtract 2x. So we get that negative 8 is equal to 3x minus 2x is just x. So we get that x is equal to negative 8. And since negative 8 is not one of our restrictions here, we could say that our solution set is negative 8. Okay? So now let's move on to our next example. Our next example, an example for number 7, is that we have x divided by x plus 6 is equal to negative 6 divided by x plus 6. So let's look at this. I'm going to first rewrite the expression x plus 6 is equal to negative 6 over x plus 6. And if we look at the denominator, we have x plus 6 and x plus 6. So x cannot be equal to negative 6. Because if x is equal to negative 6, we wouldn't have a solution. So looking at this, we're going to go through and solve it. So we have x divided by x plus 6 is equal to negative 6 divided by x plus 6. So if we look at this, if we multiply both sides by our common denominator of x plus 6, here, the x plus 6 will cancel with the x plus 6, and this x plus 6 will cancel with that x plus 6. So we're going to get that x is equal to negative 6. But if you look at this x is equal to negative 6, x cannot be equal to negative 6. So since we just solved it and got negative 6, our solution set is going to be the empty set or the null set. Okay? Because we got one of our restrictions. X is equal to negative 6, and we know that x cannot be equal to negative 6 because that would give us a denominator of 0. For number 8, we have x minus 3 divided by x plus 2 is equal to 0. So we'll have, I'm just going to rewrite our original equation. X minus 3 divided by x plus 2 is equal to 0. And then looking at this denominator, we have x plus 2, so x cannot be equal to negative 2. Okay? And then underneath, I'm just going to go through and solve it. So I have x minus 3 divided by x plus 2 is equal to 0. So on both sides, I'm going to divide by this common denominator. The common denominator is x plus 2. So multiply by x plus 2, multiply by x plus 2. X plus 2 will cancel with that, so we'll get x minus 3 is equal to 0. And then to get x, we're going to have to add 3 on both sides. So I'm going to add 3, add 3. So we get that x is equal to 3. And then we look, 3 is not one of our restrictions, so x can be 3. So our solution set is going to be 3. Okay? Now, number 9 and number 10 are very similar. Except for, in the first case, we have x plus 3 divided by x plus 3 is equal to 5. So, in the number 10, we have x plus 3 divided by x plus 3 equals 1. So let's look at this first example. X plus 3 divided by x plus 3 is equal to 5. So, I'm going to first rewrite the original equation. X plus 3 divided by x plus 3 is 5. And if we look at the denominator, we know that x cannot be equal to negative 3, because negative 3 plus 3 will give us a 0 in the denominator. So, if we look at this, we could say that x cannot be equal to negative 3. Now let's go through and let's try to solve this. So we have x plus 3 divided by x plus 3 is equal to 5. And now what we're going to do is we're going to multiply both sides by this common denominator, x plus 3. Multiply this other side by x plus 3. So we get that x plus 3 will cancel with x plus 3. So we'll have x plus 3 is equal to 5 times x plus 3. And if we look at this to solve, what I'm going to do is distribute this 5. So I get x plus 3 is equal to 5x plus 15. And now we have variables on both sides, so I'm just going to subtract x. So we get that 3 is equal to 5x minus x is a 4x plus 15. So I'm just going to go up over here. So if we have this, I'm going to have 3 is equal to 4x plus 15. Okay, so now I'm going to subtract 15 away. Subtract 15. 3 minus 15 is negative 12 is equal to 4x. And then if we divide by 4, we're going to get that x is equal to negative 3. But if we look here, x cannot be equal to negative 3, so this will not work. So we're going to have the no solution, or the empty set, or the null set. Okay? So now looking at this, let's look at example 10. So I'm just going to, again, just draw a line so we have it. So I'm going to have x plus 3 divided by x plus 3 is equal to 1. And then again, if we look at the denominator, just like in the last case, x cannot be equal to negative 3, because negative 3 plus 3 is going to be 0 in the denominator. And that's not, we don't want that. So x is equal to negative 3. So now what I'm going to do is I'm going to go through and I'm going to solve this. So I have x plus 3 divided by x plus 3 is equal to 1. On both sides, I'm going to multiply by this common denominator. So I'm going to multiply by x plus 3. Multiply by x plus 3. Here we'll have x plus 3 will cancel with this x plus 3. And we'll have that x plus 3 is equal to x plus 3. And if we look at that, we have x plus 3 is equal to x plus 3. And that's true for all values except for negative 3. So looking at this, we know that we have x plus 3 is equal to x plus 3. So we know that all real numbers will work. So we can say in our solution set, x is a real number such that x can be any number except negative 3. Okay? Okay, and now let's look at our last example. This is the last one we're going to do. So it says a baseball player's batting average is calculated by dividing the number of times a player got a hit by the total number of times the player was at bat. It's expressed as a decimal rounded to 3 places. So we're going to round to 3 places. After the first 10 games of the season, Samuel had 12 hits off of 33 at-bats. So now we're looking for his batting average. So how many times did he hit? He had 12 hits, so it would be 12. Divided by how many at-bats, how many times was he at-bat, would be 33. And if you do 12 divided by 33, and then round it to the nearest 3 decimal places, 12 divided by 33 is going to be about 0.364. So now it says for B, they want to know how many hits in a row would he need to get to raise his batting average above 0.500. Okay, so we want to go above, so we're going to have to use an inequality here. So we want to know how many hits, so we're going to have to add 12. So we're going to say, first, let's say, let x equal the number of hits. Okay, so if x is equal to the number of hits, we're going to have to add x to both 12 and to 33. Because we want to know how many more hits, so 12 plus x, and however many more times that he goes to bat, that's how many times we're going to have to add the 33 as well. So we have 12 plus x divided by 33 plus x, and we want that to be greater than 0.500. So on both sides, if we look at this, it's exactly like what we just did above, except for now we have an inequality. We know that x cannot be equal to negative 33, but if you think about the situation, x is never going to be negative because every time he goes up at bat, it's going to go positive. So it's going to do another positive batting, another positive time he's batting, another positive times he's batting each time. We're never going to go negative, so we don't have to worry about x not equaling negative 33. So on both sides, I'm going to multiply by 33 plus x, multiply by 33 plus x, so I'm just going to go up and over here. So 33 plus x will cancel with 33 plus x. We'll just get 12 plus x is greater than 0.5 times 33 plus x. Okay? So looking at this, now if I wanted to solve for x, I'm going to distribute this 0.5 to both terms here. And if we distribute it to both terms, we are going to get 12 plus x is greater than 0.5 times 33, or half of 33 is 16.5. 0.5 times x would just be plus 0.5x. So now we have 0.5, we have x's on both sides. We have x and we have 0.5x. So we have to get them on one side of the inequality. So we're going to subtract 0.5x, subtract 0.5x. So this will cancel, so we'll get 12. And if we have 1x minus 0.5x is going to be plus 0.5x is greater than 16.5. And then if we look at this, we're going to have to subtract 12. Subtract 12. So we get that 0.5x is greater than 16.5 minus 12 is going to be a 4.5. So I'm just going to, again, just go up here. So if we have 0.5x is greater than 4.5, we're going to have to divide by 0.5, divide by 0.5, and we know that x has to be greater than 9. So we could say that he would need 9 or more hits. Okay? And then the last one that we have, it says how many at-bats in a row without a hit would result in the batting average dropping below, so now we're going to go below 0.300. So basically, we want how many more at-bats in a row without a hit, so he's not going to get a hit, so we're not going to add x. So again, x is going to be the number of at-bats. So we want to know, we're going to take this 12 over 33. We're going to have 12 over 33, and then we're going to add x, because he doesn't get any hits, so we don't have to add x to the numerator. And we're going to say dropping below 0.33 would be less than 0.300. Okay? So then looking at this, again, we don't have to worry about his hits going negative to negative 33 because you're not going to have a negative hit. So on both sides, what I'm going to do is I'm going to multiply by 33 plus x, multiply by 33 plus x. Here this 33 plus x will cancel with that 33 plus x. We'll get 12 is less than 0.3 times 33 plus x. I'm going to distribute this 0.3 to each term. So I'm going to get 12 is less than 0.3 times 33 would be 9.9. 0.3 times x is going to be plus 0.3x. So then we're going to get, I'm just going to move this up here. So we have 12 is less than 9.9 plus 0.3x. So I'm going to subtract 9.9, subtract 9.9. So I get 12 minus 9.9 is 2.1 is less than, and then we'll have 0.3x. So if we divide by 0.3, we get that x is greater than 2.1 divided by 0.3 is 7. So x has to be greater than 7, so he needs at least 8 at-bats without a hit. Okay? And that will be all for today.